Hey guys, we are starting Chapter 9. Chapter 9 has a lot of activities we're going to do, and the first one is a reflection. So you need to know that a reflection in a line is a function that maps a point to its image. And then there's two things that it could be. I'll go through these fairly quick and then I'll explain it more in just a second. So if a point is on the line, then the image and the pre-image are the same point. That being said, if you have this line and you're reflecting this point in that line, that point is not going to move. That point is going to be the exact same point as the image. And the way that will be labeled is the first one will be P, and then the second one might be like P prime. So the pre-image will just be the normal letter, and then the image will be the one with kind of like a little apostrophe. It's called prime, P prime. So then the second option is the point may not be on the line, and if a point is not on the line, the line is the perpendicular bisector of the segment joining the points. So I'll give you guys a minute to copy that down, and then I need to scroll down to see that image, and I'll explain it more in just a second. So then for these here, this just kind of explains, here is a point that's on that line. You can see that that point doesn't move when it's reflected. And then this one here, this would be the image. When you reflect that in the line, it moves over here. And that second thing is just saying that that's going to be the perpendicular bisector, meaning they're the same distance away from the line. You might want to add this in. They're the same distance away from the line in a perpendicular direction. And when we do these on graph paper, what you're going to be able to do is just look and see how far apart they are from the line, and that's really what we're going to be doing, just kind of counting boxes for the most part. Okay, you can kind of see here, if I move the camera a little bit, that you can see that reflection. So we can put this down, and then what you can do is you can kind of use this to trace where that is supposed to be. We're tracing that shape in the reflection. Okay, and I need to erase mine a little bit because I got it a little bit off. But we can see here, mine is not awesome. But we can see here we have a rough reflection of where that's supposed to be. When we do this on graph paper, it'll turn out a lot better. But this is just a way for us to be able to reflect in any line and kind of see what's happening there. When you label those, please label them K prime, L prime, and J prime so you can see where those points are. So J prime should actually be right there on that line because that point was on that line to begin with. And if I were to get something out and measure these are going to be the same distance away from that line, and if you connect those points, they're going to be perpendicular. You don't actually need to connect those. I was just doing that for sake of example. Okay, for this next one, when you have points on either side of the line, your reflection, you're actually going to have some on each side. So I'm going to have point P prime come over here to this side, and then I'm going to have all of those other points over here on the other side of that line. So sometimes when the line goes right through those, they'll kind of be on either side. One thing that might help with the MIRA is if you just put where the points are and then connect the dots at the end. We can get kind of a rough estimation of how those reflections are going to look. Okay, we're going to do a real quick review of how to graph these lines, because you will be expected to graph over any vertical, horizontal, or y equals x line. So the line y equals 3, if it's ever y equals any number, it's going to be a horizontal line. So the line y equals 3, you would go to 3, and then you would draw the horizontal line through where y equals 3. So that would be the the horizontal line that you'd be reflecting in. If you ever have x equals some number, this is going to always be a vertical line. And for this here, I would go to x equals -2, so that point, and then I would draw the vertical line through that point, because all of those x values are going to be -2 for all of the points on that line. Okay, this next one, this is in slope-intercept form, so if it helps you to think of it this way, you can. Here, the y-intercept being 0 and the slope being 1, or think 1 over 1. What that's going to be is that's going to be a line that goes through the origin, and then each point goes up 1 and over 1. This is like a perfectly diagonal right through the middle of the corner of every box. You know, splitting that into 45 degrees and 45 degrees, a diagonal line going up that way with a positive slope. So other than those, you'll just have to graph in the x-axis and y-axis and any of these vertical or horizontal lines. This line here will be the only line that will be on a diagonal that you'll have to worry about. So just kind of keep this handy. If you forget how to graph them, you can reference back to this. If the reflection is in the line y equals 3, you're going to go to the y-axis at 3 and draw a horizontal line through y equals 3. And then each point is going to be the same distance away from that line in a perpendicular direction. If you want to use the MIRA to kind of estimate where it's going to be, that's fine. But I actually want you to count it out to figure out exactly where those points are going to be. So if I'm looking at this point L, because L is right on that line, L prime is not going to move at all. So just put another dot right on top of L, label it L prime. For K, because K is 2 units above that line, K prime is going to be 2 units below that line. So you can write that down and label it. And then J, because J is below the line, 1 unit, you're going to have to go above the line 1 unit. Sometimes this thing just like flies to the side. I'm not quite sure why. And you have J prime. So because I already have this on here for you, and you're just using your pencil, it'll probably look different enough. when you're doing the problems, it might be helpful to like do the first one in pencil, the second one in colored pencil, or do one in pen, one in pencil, just so you can see the difference between them. It'll make it a little easier. So then what you're going to do is you're just going to draw that triangle in, and you've done your reflection. You can use, again, the mirror to check it if you want, to make sure it makes sense. But almost all these we're going to do are going to be on graph paper. Okay, for this next one, reflecting in the line x equals -1, I'm going to draw that line in. So x equals -1 is going to be this line here, going through x equals -1, and it's a vertical line. Now instead of counting up and down, I have to count left to right to go to the other side of that line. And L just happens to be right on that line again, so that point doesn't move. Because K is 2 points to the left, you need to go 2 points to the right of that line. And be kind of careful, sometimes kids like go to the axis or something. Make sure you're going to the line you're doing the reflection in. And then for J, it's 1, 2, 3, 4, 5 points away from that line. So you just go 1, 2, 3, 4, 5 points to the other side. And then what do you guys notice about those triangles in either case? Okay, the reflections are opposites of each other. What else do you notice about the size of those? They're the same, they're congruent. Okay, so these should always be congruent figures. Okay, if the size changes or if they look different, then you did something wrong. Okay, so checking to see if they're congruent, just a good way. So for this next one here, we're reflecting in the x-axis. I still like to just kind of trace over where that is, even though you have that line there, just so you're remembering, you know, where you're doing the reflection in. And then each of these points is just going to be the same distance over that x-axis. So since R is 2 points above, you're going to go 2 points below. Label it R prime. Q is 4 points above. You're going to go 4 points below. Label it Q prime. T prime will be here. And S prime right there. And there is that kite just being reflected over. They should look like mirror images of each other when you're done. You guys doing okay with these? Yeah. The reflection across the y-axis, the y-axis being right here. Again, because now you're going kind of left and right to be perpendicular to that line. S is 1 point away, so you go 1 point in the other direction. Please make sure that you're labeling these. S prime, P prime, R prime, etc. P prime is 5 units away, so you go 5 units to the other side of that line. R prime being 2 units away, so 2 units there. And Q prime is 4. We should end up with a congruent transformation with this reflection. And one of the reasons it's so important to label those points is if I didn't label those points, I could almost think that this is just a translation if I didn't have those points marked. But you can see here S to S prime, that's not a translation, that is a reflection. So make sure that you're labeling those. Okay, and then this last one, this is usually the toughest one for students. All of these have like shortcut tricks. I don't normally write those out, but for this one here, I will write it out in the end. Maybe a shortcut, and if you're going to remember one shortcut, it might be for this one here. So the first thing I need to do is draw that line in. Remember, that line has a +1 slope. It goes through the origin. It's going to be really important that you go through like the very corner of every one of those boxes when you're drawing it in. So if you need to like put the points on there first and then draw the line, that would be good. And then here's the tricky part. You have to kind of look at this as if you're going exactly diagonally the opposite direction. Okay, because you cannot just like count across this way and expect to have a good reflection, because they need to be, oh, there's, okay, so make sure you pay attention to this, because this again is like the hardest one out of all of them. Once you get it, it's not too bad, but this is the one that kids struggle with the most. Okay, so it can't be just like straight across or straight down. We need to go in the perpendicular direction to that line. So the perpendicular direction would be like having a -1 slope, or going through the corners of the boxes going like down and over. So if I'm looking at T, it's like one diagonal of a box away. I'm going to go one diagonal of a box in the other direction and label that one T prime. So this point here was at -1, 1. This point, the image, is at 1, -1. Okay, for you, I am going directly perpendicular to that line. So through the corners of the boxes, just the other direction. So when I'm going there, that's 1, 2.5 units away. So I'm going to go, that's half, 1.5, 2.5 units away that way. And I'm going to go in and just kind of like clean some of that up. This point here is U prime. This coordinate is 3, -2. U was at -2, 3. Okay, let's look at S. S is out here. If I go the diagonals, I'm at 1, 2, 3, 4 diagonals of boxes. I'm going to go 4 diagonals the other way. 1, 2, 3, 4. That's going to put S prime here. S prime is at 3, -5, and S was at -5, 3. Do you guys notice a pattern?
Yeah, so it's like switching around.
Yes. So this again is maybe the one rule that I might memorize if it's hard for you to see where those diagonals of boxes are. If you want to memorize this one rule, that might be okay. Only for this line, the rule is you switch the order of the coordinates. So if the coordinate is x, y, you switch it and it's y, x. The negative signs are still there, you just switch the order. So let's do point V that way. V is at 1, 4. Where would V prime be at? Or I'm sorry, this is -1, 4, yep. So this one would be at 4, -1. So this is that reflection. You could check it with a MIRA. If it doesn't look right, you could always check it that way. Okay, a couple different ways that you could do that. Questions?